In this course, we wrote a lot of code and we tested a lot of code, of course. We always tested it manually by simply clicking around in our web application. In this module here, we'll dive into automated testing. That means we'll write code which will actually test our code. So code that runs to run our code and evaluate the results. This is indeed what this module will be about. We'll dive into what exactly testing is and why we use it. We'll have a look at different kinds of tests, namely unit tests, integration tests, and end-to-end tests. And we'll also explore how we can test both synchronous and asynchronous code, and in general, get a thorough introduction into the world of testing. Now, what is testing and why would we want to test? Now, testing, when you hear it for the first time, sounds pretty obvious, pretty straightforward. We are writing an app, we're creating an application, and we simply test it, right? We add a feature, we open the browser, and we test our application. And that is indeed how you will continue to work, even if you do add this kind of testing I'll dive in this video. So testing manually still is something that makes sense. You want to see your application run. So in the end, the idea always is that we have our code and we have some expected result. So if we write some code and then we go into the browser and test this code, we have some idea of what should happen. We want to open that modal, we want to add that user when we click that button, something like this. So we have our expected results in mind, and then we simply test our application. And if we are successful, we are fine with that. We can continue with writing the next piece of code. And if we're not happy with the result, well, then we can modify our code and fix the issue or adjust it such that it works in the way we want. Now, the idea of JavaScript testing or code testing, when you read it like this, is that we automate this testing part. So that we automate it so that we don't have to manually test everything in our application. Now, we will probably still test everything manually, but automated tests can be run whenever we change something in code to see if that affects any part of our application without us having to test everything manually again. That is the idea behind automated testing, that we can see breaking changes or issues in our code, maybe introduced by a change in place A in a totally different place of our app, that we can see this instantly. That is one of the major benefits of writing tests. So that is also one answer to the question, why would we want to test? We want to get an error and see the error if we break our code. We want to see that immediately without us testing everything manually. We might still do manual testing, but it's still worth a lot to have a suite of predefined automated tests that we can run to quickly see, did this change break anything? Well, with well-written tests, we'll get the answer right away. We'll also save time if we don't have to test everything manually over and over again. And we are also forced to think about possible issues or bugs when writing our tests. We have to think about, what do we want to test? How do we write a test that makes sense? And I'll dive into that in this video already. We also can integrate it into our build workflow. This is something more advanced, but there I mean that you could have a build workflow where you push a commit, so a git commit to your code repository like GitHub, and then you have a workflow that automatically is triggered where this code is then tested in the cloud on some server, and if the test succeeds, it's maybe deployed automatically. So you can build a very complex deployment chain there, and tests are then an integral part of ensuring that no breaking or invalid code is deployed. So that is also an advantage of tests or something you can use tests for. We can also break up complex dependencies, and that is also something I'll show in this video. We have to make sure we write code that can be split up, that is modular, because this will make testing easier, and ultimately it will make working with our code easier. And it improves our code, therefore. Since we are forced to follow certain patterns or to write code in a certain way, or at least that will make testing easier, we will write better code altogether. So these are a lot of great advantages, but they might still be a bit abstract when you have not written any tests. So let's dive into testing soon, but not before I try to answer one other question, and that is, which types of tests do we have? I'm talking about automated tests, so some code we write that tests our code, So code that tests code. That is a good description of what testing is, or what automated testing is, I guess. And there we have different kinds of tests. We have some tests that test a fully isolated piece of code. Let's say a function that takes some input and returns some output. We can test such a function with a test because it has a clearly defined structure, and we can say for input x and y, we expect to get output z. And that would be a so-called unit test because we test a single isolated unit of our application. We also have some tests that test units with some dependencies. So we have no isolated piece of code anymore, but we might have a function that calls another function, let's say. And therefore, the function we're testing depends on the result of another function. And that is called an integration test, because there we're testing more than just a single unit. We test the integration of a feature into another feature, so to say. We also have the full flow, which we can test, or the user interface, so the full application or a part of the full application. And this is a so-called end-to-end or also user interface test. The idea here is really that we do what we could do manually as well in the browser, but that we write kind of an automated script that executes a certain series of steps for us, and then we can check if the result is the result we expected to get. Now, these kinds of tests have a different complexity. Unit tests are relatively easy to write because you have a small unit and you know it's easy to infer what you want to get as a result. The more dependencies you add, the more complex it becomes because it gets harder to differentiate between what exactly is causing an error. Is it a dependency or the function that uses the dependencies? Also, you might have some dependencies that reach out to a server and fetch data. That is also a complexity you have to handle, and I will show you how to handle this in a separate video. And the full user interface test is the most complex one because there you have to define every step that should be executed and cleverly think about what you want to test and what you want to expect there. Now, also due to this complexity, we write tests in a different frequency. We typically have a lot of unit tests because if you test every unit of your application and it works correctly, you can kind of infer that the overall application will also work correctly. So we will have a lot of unit tests. We then have some integration tests to rule out that two individually working units don't work anymore if you combine them. And we have a few UI or end-to-end tests to test some steps or some flows in our application in the browser in an automated way. So these are the kinds of tests. And in this video, I will show you all three already. And with that, I'd say it's enough of the theory. Let's start writing some tests. For this, I prepared a little starting project, which you of course find attached to this video. And you can simply download that, run npm install in the extracted folder to set up all the dependencies I have here. I don't have many dependencies, I only use Webpack. And then we have a very simple application here in app.js, a JavaScript application, front-end JavaScript, where I import some stuff and then have some code to basically set up an event listener to a button and add a user to a list of users when we click that button. I got util.js, which holds the functions I'm importing into app.js. I'm using Node.js module syntax here simply because that's a bit easier to test and doesn't require a complex build workflow setup on which I simply didn't want to focus in this video. But I use Webpack to then bundle this all up and get a main.js file, which is the file we then use. Now what you can do is you can simply double-click index.html. I got no dev server in place here or anything like that, simply to not focus too much on the front-end workflow. And if you did double-click on that file, this is what you'll get. You can enter some data and add a user, and that is all we can do here. So it's a relatively simple app, but that is great for starting with testing because we can easily confirm if our tests make sense. If they do test something, we would test manually as well. So this is the application, and now let's write some tests. Now, for writing tests, we need some tools that help us with creating these tests. What do we need? We typically need three kinds of tools. We need a test runner, which is simply a tool that executes our tests and summarizes the results and gives us some output on the results. We can use something like Mocha there. That is a popular test runner. We also have assertion libraries, and there we define our tested logics, our expected outcomes. So these assertion libraries give us tools to define expectations, to define comparisons, conditions we want to check as part of our tests. There, Chai is a common or a popular assertion library, though what we will use is a very popular library for both running tests and asserting, and that is Jest. Jest is relatively new, or at least it was rewritten not that long ago, and it's a very popular library for writing tests because it is both a test runner and an assertion library, and it's really powerful and a lot of fun to work with. For end-to-end, we also sometimes need a headless browser, so basically a browser where we don't have to click manually, but where we can use the browser API, the DOM and so on, without a user interface necessarily, because we'll analyze it in code anyways. And there we can use Puppeteer, which is a very popular solution for that. We need that headless browser mostly for end-to-end testing, whereas the test runner and assertion library are also needed for that, but also then are the only things we need for unit and integration tests. Now let's start with Jest and with unit tests. And you can simply Google for Jest to find jestjs.io, the official webpage of Jest.js. And there I can only recommend trying that out, getting started, diving into the official docs to learn way more. But of course, I'll also walk you through all the basics in my videos here. So we'll start installing Jest now. And for that, let's switch over to our project. And in there, let's run npm install --save dev Jest, because Jest will be a development dependency of our project, and it will be the tool we use for running our tests and for checking our outcomes, or for writing some conditions, some assertions as it's called. So this will now install, and with it installed, we can write our first test. And I will write my test for functions defined in util.js. And there, this first function makes up for a great first unit test. It has no other dependencies because it does not call any other function, it does not reach out to the web or anything like that. It simply takes input, 2 arguments, and returns an output. And this would be a great example for a simple unit test we can write. Now, to write a test for this function, you create a separate file into which you'll store your tests. And you typically name that file like the file you're testing, util, and then .spec or .test.js. The name is up to you. Jest will automatically detect files with .test or .spec in them and will run them automatically once you run Jest, which we'll do in a second. So now I have my util test.js file. And now I want to test my generate text function. For that, I first of all need to import it here. I will use destructuring syntax here to require something from util, so from that util file where the code is stored. And then destructuring syntax simply means I pull out some items from the object, which is in the end exported by the util file, and it will pull out the generate text function. So essentially, I import the generate text function into my util test.js file. And by the way, this is the native way of importing in Jest tests. You could think that you can also use like ES6 imports if you had respective exports in your file, of course, something like this. But this will not work. Not only because I'm not using ES6 exports here, that is also a problem, but even if I would use them, this is not a syntax natively supported by Jest. This Node.js-like import syntax is supported by Jest, and therefore I also wrote my code to use Node.js exports because that made it easier to implement Jest. Obviously, you can also make it work with ES modules, like you use it in React or Angular apps, but there you need a more complex build workflow, you need some additional packages, and I did not want to spend a lot of time on the setup, I want to spend time on testing. Therefore, I use this syntax. So now I'm importing generate text in this file. Now we can write our first test. And for that, we can simply write test here. This is a function which is now globally available, or which will be globally available when we run our tests with Jest. So this is a function provided by Jest in the end. And this function allows us to define a single test. Now, we can give that test a name. That's the first argument. Or not really a name, more of a description, you could say. Something like should output name, and age. Typically, you kind of define what you want to test in this name or in this description. So which output are you testing for? You try to put that into your description. Ultimately, you can put whichever text you want in here, but it should be kind of descriptive. The second function argument is then an anonymous function which you pass in, which is the function Jest will execute to really run your test. So in this function, you add your testing code, your code that will be executed. And now here, we can generate some text by calling generate text and storing that in a text constant. And there we'll pass in max and 29, let's say. Now, that is also what I tested here manually. Entering max and 29, added a new item with text max and 29 years old. Now I'm effectively testing that part where this text is generated. So not where the whole item is generated, but only this text. Max 29 years old is what I expect as an output of generate text. Because if we have a look at generate text, well then we return a text here where we have the name and then in brackets 29 or whatever the age is, 29 years old. Now, if we have that expectation, we should formulate it here in the test. And we do this with the expect function, which is also provided by Jest. Now, if you would use a different setup with, let's say, Mocha and Jai, then test would be a function defined by your test runner, whereas expect would be a function provided by your assertion library. And most assertion libraries work with the expect function, because tests are pretty descriptive in terms of function names. We write a test, and then we expect something. Now here, we expect that text, so we pass the thing we want to look into, we want to compare. We expect text is equal to a specific text. And we do this with a bunch of helper functions that we can now chain on our expectable object here. And there you see we have a lot of functions where we could say we expect text to be not a number, for example, or to be null, or just to be. And then here, as an argument to the to be function, we pass the value we expect text to be. That could be a number, but that could be also max 29 years old, which is exactly the output we do expect to get, because it is the output we can also see here. And now with that, we have our first test defined. Now to run this test with the Jest package, I will tweak my package.json file. There we have Jest installed. And we have a script up here, the test script, which is kind of invalid right now. Here, I will just run Jest. And this will automatically search for files with .test or .spec in the name and execute them. Or which end with .test.js or .spec.js, I should say. So now with that added, we can simply run npm test down there in a normal terminal, navigate it into the project folder, and Jest will automatically execute all our testing files. And here we get a beautiful green output. It found one test which passed. And there we see the one test which passed successfully, where it should output name and age, and that succeeded. Now this is great because now, if we ever change something here, let's say we accidentally output the age here too. We change something in that function, in the original function, and we break it. If we save this and then we run our tests again, we now actually get a failed test. And that is exactly where tests can help us a lot. We get a failed test, we see which test failed, should output name and age, and Jest even gives us some information on what failed there. We see that we expected max 29 years old, but we got 29 years old. And this now helps us debug our code and fix our code. Of course, this is kind of a constructed example here, but you could have a typo like this. You could be misusing some variable or some argument. And now if we fix that, we can indeed run this again and get that test passed. By the way, you can also watch with Jest. You can add -- watch here. And now if you run npm test, Jest will actually keep on watching. And you can control the watcher with the shortcuts that are shown there to, for example, force a run of all your tests again, or whatever you want to do. And it also means that now, if I do change my file here and I save, Jest automatically reruns my tests. So this is great, having this run all the time and therefore ensuring that we get errors right as we change something. So that is another great option. And that is our first unit test here. Now this is our first simple unit test. Now before we move on to integration tests, just a quick example for a different kind of test that could also make sense. We should also make sure that it does not just return the valid response here, because we can get this with this trick as well. If I copy the output there, I can also just use return and then this text here. And if I do that, then my first test will always succeed. If I quickly comment out that second snippet. So my test will now always succeed, but I have an error in my function. And we have a second test where we can add a second test where we confirm that this is not the case. So let's say we say should output data less text or whatever you want to name it. And there I could also generate a text with generate text, but I pass an empty string and I pass null as a number here. And then I can expect that text should be, well, what should it be like? It should be basically just a blank and then nothing years old, right? Well, let's give this a try. If I save that, it fails because I always get back max 29 years old because I broke that function. I had a false positive for the first test because I returned the value which I expected there, but the value didn't take the inputs into account. Now I can fix this, of course, and return to the function form I had before. And now the second text will fail because there, whoops, I should expect null years old, of course. I passed null, not nothing. And now there I passed 2, and I have confirmation that I don't have a false positive here. So adding a second test like this might make sense as well to kind of check for the opposite or check the same thing with different arguments, though you could do the same in one and the same test. You can have multiple expects here too. So you could generate Anna 28 here as well. And then simply add another expectation here, text 2, to be Anna, 28 years. And now this should also pass. But having such double checks, that is the main thing, can make a lot of sense to avoid false positives. And here I have a double check as well as testing the opposite. So what happens if I call that function incorrectly? What happens if I pass nothing, for example? Well, then we would expect undefined here, right? And that would be a test that could also make sense. So I'll delete that for now. I'll leave it at this simple unit test, but you should be aware of the fact that you can write multiple unit tests for one and the same thing, then you can check more than one thing in a unit test, and that you might also want to check for false positives or for opposites. But now let's move on to integration tests. So let's now write an integration test. And for integration testing, if we have a look at all our code, which function could we use there? Well, we got in the app.js file, we got add user, which uses a lot of other functions, which has a lot of dependencies. So testing this function would be an integration test, but this is a function that does neither take an input nor return an output. Instead, it's a function that really added something in the DOM. So this is something which you might want to test in an end-to-end testing scenario or in a user interface test, but an integration test would be kind of hard here. We would have to do a lot of manual DOM interaction inside of our test, which you can do, but which you might not want to do. Instead, there is something else I can test, and that is basically a part of that function, you could say. In the end, what I'm doing in add user is I do select a couple of elements, then I do validate the input, and then I generate a text based on the input. Now we could outsource this into a separate function, and that is the part of writing modular code that I mentioned earlier. You are forced to write modular code, which also makes your code easier to manage and reuse though. So in util.js, I can export a new function, and let's name it check and generate or whatever you want to do. Now check and generate will get a name and an age as an input, and then I will go to my app.js file, And I will grab that validation code and move it into check and generate to validate input for, and now that's important, for the name here, and then there for the age, like this. And then if we make it past this if block, I will return a call to generate text where I pass name and age, because that is what I then return here. I return the checked text. So in app.js, where I'm using this, output text is in the end just the result of my call to check and generate. I don't need validate input here anymore. I don't need generate text anymore. I'll just import check and generate, this new function. I'll import that in app.js. And down there, output text is the result of check and generate. And I can move that up here. And here I can now simply check if not output text. So if we did return, let's say, false here, we return false if validation fails. So if this is returned, and therefore if this is not truish, if it is false, for example, then I will return an add user to, and I will not continue creating that element. So now this is the tweaked add user function, and this gives us the check and generate function, which is great to use in an integration test. So let's write a test for it. And I want to test if my validity works correctly, and I then get the expected text back. So it should generate a valid text output, or something like this. And then here in this function, I will test my check and generate function, which I therefore have to import. And I can simply create my text with check and generate, and I pass max and 29 here. And I would expect this text to be equal to max 29 years old. So my expectation actually is the same as in this unit test, but it's not a simple unit test because the function we're testing has more to it. We could fail because validation fails, or because generate text fails. However, generate text is kind of ruled out because we have a separate unit test for this. And this is also how you want to write your tests, by the way. You want to ensure that you drill down like to the smallest possible level and write unit tests for all your units. So write a test for generate text would also be worth writing one for validate input. And then your integration tests really just rely on the units being tested and ensure that the units also work together well. So this is then the idea behind an integration test. So here I have this test, and if I now save this, it actually fails. Now I get an error that validate input is not defined here. And that is true because I do export validate input. I don't need to do that anymore. I should instead create it or define it as a constant. The same is true for generate text so that I can use these functions directly in the util.js file. And then at the bottom, I should also export generate text and assign the generate text constant here, and also export validate input maybe and assign that constant so that I could use it in other files too. And now you see my tests passed. Both tests passed. Now the idea about the integration test is that if I do change something in my check and generate function, for example, here I use my validate input function incorrectly, so the result of that is used incorrectly. Now it fails. And now this is a great example of why I have an integration test. I could have a separate test on validate input, and validate input does work correctly, I can tell you that. But my error is directly here in check and generate. I'm using the result of validate input incorrectly by not checking for it being false, but for it being true. And this means if my name is valid, then I actually return false, which is of course the wrong logic in check and generate. So even though my units work correctly, the combination of the units fails because I have an error here. And this again shows you the power of tests and why integration tests make sense too, and unit tests alone could not be enough, because all units could be working. If you're combining them incorrectly, you still have a problem. So now it's working again though. Now that we had a look at unit tests, what they are, why we use them, and integration tests, let's have a look at end-to-end tests or user interface tests. For this, I'll need to install another tool. So I'll quit my jest process here, and I will install with save dev Puppeteer, which is a headless version of Chrome, of the Chrome browser. So it basically is a browser we can use to interact with the DOM and so on. We can even run it in a version with the head, so where we see the browser. And we can basically define steps that should be executed in that browser so that we can automate certain processes on our web page and then, of course, test the result of these processes as well. Now, this download will take a while because in the end it downloads the entire Chrome code base because, well, it needs that to be able to simulate that browser. And once it's done, I'll be back. So I'm done installing it. Let's start using Puppeteer now. And for that, I'll go to my util test.js file and I will import Puppeteer. So I'll import Puppeteer by requiring it from Puppeteer like this. And I will write a new test now. And there I will just write should click around for now. We'll fix this later or change this later. And in this function, which should be executed here, I want to use Puppeteer. Now, how can I use it? First of all, I set up a browser by using Puppeteer launch. Now, this will launch a browser with some options which I can define here. For example, I can set headless to false to actually run a browser with a user interface as well. You can set a bunch of stuff here, and you can find it all in the official docs of Puppeteer, of course. I will also set slow-mo here. That will basically slow down the automated operations so that we have a chance of seeing what's happening. And I'll set it to a value of 80. And we can also set some args here, which is an array, where I can pass dash dash and then, for example, window size to launch this browser with these arguments. And window size allows me to set a width-height pair. So I can set this to 1920 and 1080, for example. Like this. This should launch a browser with this size. And that, of course, can be great to also test if certain responsive features are working the way you want. So now this will create a browser. Now, actually, this will return a promise. So we can use async await here if we want to by placing async in front of this pair of arguments here, or this empty argument list. And now we can await this to launch. The alternative would be to just use then and catch. Async await in the end does this for you. So here I'm awaiting this and storing the result in browser, you could say. As a next step, I can now create a page object by awaiting the browser to create a new page, like this. Now I also need to tell the browser which page to load, and I'll grab my URL here. And then we can say page, go to, and then you enter your URL, which should be loaded. And you also should await this because all these browser-related things are promises that simply take some time to execute. So you have to await each step. So now this should open a browser and load this page. Let's try this by running npm test. And it should indeed open up a brand new window in Chromium, which is basically like Chrome or the core functionality of Chrome. And you also see that this is being tested, controlled by automated test software. So this was opened automatically. Now let's go back and let's add some logic here. We don't just want to go to that page. Let's say we also want to enter something. For that, I want to enter something into my input with the ID name and age. So in my test, I will await a step where I use that page, where I navigated to my app, where I will then click into the field with that selector. So click takes the selector of the item it should click on. Once I click there, I will type. And again, you can find all commands in the official Puppeteer docs. So you can really instruct the browser, the headless browser, what to do. So I want to type, and I want to type into the same input, and we wouldn't have to click on it first, but I want to simulate all the steps a user would do. And I want to insert, let's say, Anna here to mix it up, not always Max. So now I type in there. I will repeat these steps once I type the name for the age. So for the age field, I will enter 28, let's say. If you save that, it will open up a new window where you can see that it enters these things. Now we can also add another step and click on this button at the bottom of our page. So in app.js, in the end, it's this button we're listening on for an event. Here with ID button add user, we can grab that selector and make sure we click on that in our setup. And now we get a full flow setup where you see that this gets entered and then we click this button here at the end. You also saw that it didn't add an item. And this already shows us that writing this text was not the worst idea, because it looks like something was broken. And indeed here in our automated test, if we open the developer tools, we see that it didn't find the validate input function here. So since that was missing or is missing, we have to check our util.js file and see what's wrong with validate input in here. I'm using validate input here, and I'm defining it as a function here. But one thing I never did is I never recompiled my code. That's something we have to do because the code that gets imported in the browser is packed with Webpack. And I never recompiled it after changing my code. So in a separate terminal window, I'll quickly run npm start to get Webpack to run my code. It'll now also watch my code and recompile if I change something. And with that, it should have executed your test automatically. In case it didn't, simply add a blank and reopen your browser and enter, and it will reopen the browser and execute this. And now you see this works. And this is Puppeteer being used for automated testing with a graphical user interface. Now, obviously, we can automate this a bit more and check the result programmatically now to see if we got the expected outcome. Because what I can now do is I can also await, and now that everything executed, I can check if something is the case. For example, I can check for the existence of this list item with a class of user item being added to it. So in my test, I can await my page, and there I can use $eval to get access to an element. And I will look for the first element with a class of user item. And I pass a function as a second argument to eval, where I then define what I want to do with the element I selected there. And here I will get an element as an input, and I will, for example, return the text content. And this means that now the result of this function will be returned by this overall promise, so I can store it here. Final text, for example, will be the text that I fetched from this element that was created. And now I can expect final text to be Anna, 28 years old. Now it's again checking for that text, but it's now using the full flow in the browser. It's not just a unit or integration test as we have it up there. It's really going through all the steps we would execute manually as well. And then, of course, we should have that text, but we could check anything here. We could also check for the existence of this class. And we implicitly do so, because if that class would not be there, we couldn't select the element by it, and therefore final text would certainly not be that text. But now if I save this, it executes all our steps here. And it actually fails here because it basically timed out. That's just a limit set up by Jest to ensure that our tests don't take too long. What we can do for that is the test function actually takes a third argument, and that is the maximum timeout. And we can set this to 10 seconds to 10,000 to increase the time we give our browser to complete its operation so that it doesn't time out. And now you see it finishes successfully because should click around, to which we should assign a better name, does give us the result we want. And here I will now say should create an element with text and correct class. Something like this. By the way, we can of course now also set headless to true, disable the slow motion, and not set these arguments. And this will now speed up the testing because now it doesn't have to go through that step in a real browser. It does so behind the scenes. And that's one of the advantages of having a headless browser, that you don't have to watch it execute the steps. But it can be nice to see the steps. You can do both. And now we got a full E2E test or a user interface test in place too. Now we had a basic introduction to testing now, to the core types of tests, but thus far we always tested relatively simple code, synchronous code, where nothing special was happening, where no side effects were involved, like a HTTP request going out when a function is called. Now things like that can cause problems when you're trying to run tests, because your tests will also trigger that code which might send a HTTP request, or which might do something which makes the test take longer, might hit a backend API, or might distort results. So now we'll have a look at what we can do to make our tests simpler and focus on the core things and really only test what matters to us. So for this, again, I prepared a starting project, which you find attached to this lecture here so that you can follow along. And if you start the project by double-clicking the index.html file, you'll see a button there. If you click that button, you will eventually see an all uppercase text being printed here. Now, responsible for that output is this code here. I got a very simple setup here using Webpack. And here I'm getting access to a button in my DOM. I'm adding a listener to print a title. In print title, I call load title, which is this function here. In that function, I reach out to fetch data, which is provided in a different file, also created by me. There, I seem to get some data object, of which I extract the title. I then transform this title to be all uppercase, and I return that, hence I can print it here. Now, if we have a look in this HTTP file, into this HTTP.js file, here I'm using a third-party package, Axios. So this is not written by me, this is another third-party package. And here, in fetch data, I make a GET request to a dummy API. So this is a real API in the web. A real request is made here. This API is not maintained by me. It's just an API we can use for playing around, for testing. And there, I get back a response object. Axios gives me such a response object, which happens to have a couple of properties, like the status code, for example, but also the data property, which I'm extracting here. This is essentially what I do. Now let's write some tests. I already installed the jest package here, and I also already configured my test command here to use jest. I also have a project where I use Node.js import-export syntax, because jest uses that by default, and just as with my other testing video where I gave you an introduction to testing with jest, there I explained that jest uses that syntax, that setting it up to understand a different syntax would be more complex, and I still don't want to do that here, because here I want to focus on testing async code. So we got everything set up to write some tests, so let's do that. You learned in that last video that you can create a new file with .test.js at the end to have jest.js pick it up and execute it automatically. So this will be the testing file for app.js. And let's say we want to test print title. Conveniently, I'm already exporting it here at the bottom. So what can we do? Well, in app.test.js, we can use the test function, which is globally available when we run that file with jest. There we give it a description, some text, some description of what should be tested here. And there I have should print an uppercase text, for example. I have my arrow function then that should execute, or that contains the testing logic. And in there we define our expectations. Now we could expect uppercase text with the help of some regex magic or anything like that. But here, because we'll change that anyways, I just want to expect this text, because right now I will always get that text for the API endpoint I'm hitting. So I expect, and now I need to import that function, which I want to test. So that will be print title. I'm pulling that out of my exported object in the app.js file. So I expect print title, the result of that function call, to be equal to my all uppercase text here. This is my expectation. We can now run that test by running npm test, and this executes all test.js files. And this actually fails because it fails to execute add event listener of null. Now, the reason for that actually is that app.js contains some code that will always run when this file gets executed, and it does get executed when I import from that file. And it tries to access the DOM here, which just doesn't work in this environment here. The real DOM is not loaded here. So an easy way around that is to take that function and export it into a separate file, maybe a util.js file. This is also something we did in the last video already. Export print title here. And what this allows us to do is it allows us to import something from that file only without executing app.js and therefore without hitting the real DOM. So we can rename that testing file here to util.test.js and we import print title from ./util. And in app.js, since I removed print title from there, we also need to import print title by requiring it from the ./util file here. And now for that to work, I'll also have to move load title over to util.js because print title depends on that. So let's move load title into that file as well. That means that fetch data also needs to move in there. So from app.js, let's grab the fetch data import and move that to the util.js file. And now with that setup, if we rerun npm test here, now it should be able to run our test here. And it does, but I get an error that essentially it expected a string, but it received undefined. And now this already shows us a problem we have with asynchronous code testing. Well, actually in print title, I am indeed returning nothing. So getting undefined as a result makes perfect sense. But even if I would return something, like for example in here, if I not only log the title, but I also return the title in here, if I do that and I rerun, I will still get that error. I can already say that. The reason for that is that, and that has nothing to do with testing, that's normal JavaScript behavior, return statements inside of callbacks or inside of promise then calls are not executed or are executed, but JavaScript does not wait for them. It does not return this value as a return value for this overall function. Instead, this is the return value of that inner function here. And we're not testing this inner function, we're testing that overall function. So in our case here, one simple solution would be to test load title. Here we return something in the inner function, and we also return something in the main function. We return the whole promise. So chances are that we get back a promise here to which we then can listen, and that might allow us to expect something helpful. So let's change something. Let's export load title here so that we can test it. Let's go to util.test.js, and there I will not expect something like that, but I'll get my title. But instead, I will import load title here, and I will execute load title, and this gives us a promise, so I will add then here, and in there, I know I'll get my title, because that's exactly the way I use it in print title, right? I have load title, and then I get my title. So now I have the exact same usage here in util.test.js, and now here I want to expect something that my title should be equal to that, to that uppercase title I got here. So we can grab that title here, copy it, and that is what I expect as a value. Now if I rerun npm test, it actually passes, because now this test succeeds. So this is better, this is how we could test our asynchronous code, but we still have a problem here. The problem is we're still hitting our API. So here in util.js, I'm using fetch data, and if you remember, we're defining that in the HTTP file, so here, and there we're making a real API request. We typically don't want to do that in testing. We might exceed certain API quotas if we do that. If we're testing post requests, we might even edit something on the API, which we certainly don't want to do as part of testing, certainly not with our production API at least. So hitting the API is typically not something we want to do. There also are other reasons against it. What would we achieve by really making that HTTP request? Do you want to test if your API works correctly? If you're building that API, you should do these tests during the API development, not when working on your front end. These two should be separated. So that is certainly not something you want to test. If the API works or not is not something you test in your front end code. You might test error fallbacks or anything like that, but not if the API works correctly. You also don't want to test if the get method exposed by Axios works correctly. That is a method provided by a third-party package, and we rely on that package doing its job. So we also don't test third-party package functionalities. We want to test our own code. And our own code here, for example, is that we extract data, and that here that we transform this to uppercase and that we pull out the title. Now, to focus on that, we do something which is called mocking. We mock features, which means we replace features we don't want to test with some dummy implementations. And how could this look here? Well, in util test.js, we got load title, and we want to test if that successfully transforms our title to be all uppercase, to be this text. Now, to test this, what we need to do is we need to replace fetch data with a mock. Now, Jest gives us a great way of preventing us from using that fetch data method. We can create a new folder called __mocks, all lowercase, __, next to the files that contain our raw source code. So in this case, in our root folder. Now, here we can add a http.js file, so the same file name as the file that has the function we want to replace. And now in HTTP.js, we can now do some magic to set up some functions that will replace our real functions when running the tests. For that, I'll copy my code from HTTP.js. I'll get rid of Axios though, because I'll not use that here. I'll still export fetch data though. But in fetch data, I'll simply return a promise which I instantly resolve with promise resolve to an object that has a title property with the text I want to test, which I'll now convert to all lowercase though, so delectus autumn. And now that I'm exporting this here, something interesting will happen. In HTTP.js, I added a console log statement to fetch data to see when we're hitting this API and when we're not. If I now run npm test, we are hitting the API, as you can see here. We have that console log statement from the HTTP file in there. Now we can go to util test.js, and in there, we want to add just mock at the beginning and mock the HTTP.js file, like this. You can omit .js though. Now if we run npm test, you see, it also took close to a second because it had to do some magic behind the scenes, but you don't see that console log statement. Because what now happens is, when this test gets executed, when this testing file gets executed, Jest goes ahead and replaces the HTTP file with our mocked file. So all the functions that are exported here are then replacing the functions we are normally exporting in the real HTTP file for our tests only. So for the tests only, we use our mocked functions here, so this dummy fetch data, which gives us back an object that allows the other functions to work fine, but which does not hit the API. Because we don't want to test the API response, and we don't want to test the access get method. So we can rely on the API returning us an object that has a title property, and we can rely on the access get method giving us an object, a response, which has a data property. So we don't need to test that. We want to test whether our code in the util.js file correctly extracts the title and transforms it. And that is the case. Otherwise, this test would not have succeeded for our mocked implementation of fetch data, where we return an object with a title that is all lowercase, so not what we test for, lowercase, this text. And therefore, since our test succeeds, we know that our transformation here does work. So this is how we can test async code, or how we can replace code, how we can replace functionalities if we don't wanna, in this case, hit the API. The same would be the case for, let's say, code that accesses the file system. You don't wanna do that. Instead, you wanna mock such functionalities. You can, by the way, also mock global packages like Axios itself. Instead of mocking our fetch data function, you could create a axios.js file here, and there we could export our own get function here, which we, of course, have to define. Because remember, in my HTTPS file, I am using the get method of the axis object. So here I want to export a get method, and that should be a function that takes a URL as an argument, but we don't care about that URL here. What we want to do here is we can return an object, which in this case, since this is faking the response from Axios, so we want to fake whatever get gives us back, and that should be a response object which at least has a data key because we're extracting that. So here in the Axios mock, we want to have a data object which should in turn be an object with the title we want to test. So that lowercase title we defined here. So basically we're now mocking a functionality which is one level above the last functionality where we mocked our own function. Now we're using or we're mocking the function this raw function, so this function depends on. So now in the Axis.js mock file, I'm returning an object which has a data key, which has an object as a value, which has a title key, which is the lowercase version of our text. And with that being mocked, we can go to our util test.js file. We can comment out this mocking of our HTTP implementation. So we'll now not use this HTTP file we created a second ago. Jest.js will automatically use mocks of global node modules though. So Axios.js, this mock should be used automatically. We don't have to instruct Jest to do that. And now we can simply run npm test. And here it fails because what I return here is not a promise. And this already proves that this mocked file is being used. Otherwise, it would not have failed. I'm returning an object there, and therefore calling then fails. I, of course, have to return a promise here by using promise resolve, so a promise that eventually yields this object. And once I do that, and therefore my mocked get method provides a promise as the real Axis implementation does, once I do that, it passes again. We see fetching data here because we are now using my original fetch data implementation, but the get method we're using here is not the real one, it's our mocked one. So this one here. Now this is how you can mock certain functionalities to test async code or code in general, which might depend on third-party packages. Now there are other strategies as well. You'll also find the term spies or stubs when you venture deeper into testing, and you can definitely also check out these alternative approaches to learn about alternative strategies for working with async code and third-party libraries. Attached to this lecture, you'll also find additional resources that allow you to dive deeper into these topics and into Jest in general, and learn more about testing and build up on the knowledge you gained here.